Okay, what we're going to do here is we're going to work out the volumes, and I'm going to do surface area actually of each of these shapes. Okay, so we've got a sphere. Now the first thing to do, you get this in exam, is you look at the formula sheet and get the correct formula. So the volume of a sphere has this formula here, 4 over 3 pi r cubed. So the volume is equal to 4 over 3 pi r cubed. So a simple case here of substituting into the formula. It's 4 over 3 times pi times 7 cubed. Just put that exactly correctly into your calculator. So 4 times pi times 7 cubed. And then divide your answer by 3. I get, let's say, to 3 significant figures. Oh, hang on a second. Sorry, I'm having a calculator nightmare. 4 times pi times 7 cubed divided by 3 equals to 3 significant figures 1440 centimeters cubed. That's simple. Okay. Obviously, if it's a hemisphere, half a sphere, then you just can divide that by 2. You adapt the formula accordingly. Okay. The volume of a cone. Let's have a look at what the formula is. Volume of a cone is 1/3 pi r squared h. Notice it's the same formula as a cylinder, except you're dividing it by 3. So it's a third of a cylinder. Okay, so it's going to be 1/3 pi r squared h, where h is the perpendicular height. So we've got all of that information there. So it's 1/3 times pi times 4 squared times 13. We're just going to put that straight into the calculator. So 16 times 13, divide by 3, and then times by pi. Sorry, again, I'm having calculator issues here. Sorry, 1 second. 4 squared times 13 divided by 3 equals times by pi. 3 significant figures, that's 218 centimeters cubed. Okay? And what about the pyramid? So let's have a look at what we've got here. The volume of a pyramid is very similar to the volume of a cone. It's a 1/3 AH, where A is the area of the base. But it's actually the same for a cone, because that pi r squared, well, that is the area of a circular base, isn't it? So it's actually the same formula. So when it's not a circular base, it's just what is the area of the base, in this case it's a square. So 1/3 AH will become 1/3 times 60 squared, because it's just a square, times the perpendicular height, which is 30. And we can, again, just throw that in the calculator. So 60 squared times 30, and divide that by 3. I get 36,000 centimeters cubed exactly. Okay, so there is my answer. So the volumes there are quite easy because all of the correct information has been given to you. Now, surface area, for some of them, can be a little bit more tricky. For the sphere, not really. Surface area, let's have a look at the formula. So surface area of a sphere, or the curved surface area of a sphere, is 4 pi r squared, and there's only a curved section of a sphere, so it's 4 pi r squared. So it's 4 times pi times 7 squared, and let's go 4 times 49, 196 pi centimeters squared. Okay, and again, I could look at this in exact form, give the answer in exact form. That's exact form right there, 196 pi, no changing it. If I wanted to round it to 2 decimal places, I would do 196 times pi, and then round that to 2 decimal places, which would be 615.75 centimeters squared. Okay, so the sphere is nice and easy. Cone, not so much. Now, it doesn't tell me if it's a hollow cone or not. A hollow cone would be like an ice cream cone where you can basically put something inside the cone. So there's no lid to it. Whereas it could also be a solid cone where there is a lid and then the wraparound. Okay. Now, we're not told, so we're going to assume it's a solid cone. So the surface area is equal to the curved surface area of a cone, pi RL. Okay? Now, first of all, 2 things there. Pi RL, that is just the curved bit. So what I need to do is add on the circle at the bottom. The second thing is, what is L? Now, L is what we call the slant height. The slant height. It's this distance here. Okay? Not the perpendicular height. It's the slant height. And we don't know what that is at the moment, so we're going to have to use a bit of Pythagoras. So we're going to say 4 squared plus 13 squared, that's L squared, equals that. So we're going to do 4 squared plus 13 squared. So L squared equals 185. So L is equal to root 185, which is 13.6 centimeters to 3 significant figures. Okay, so it becomes pi times 4 times 13.6 times pi times, plus pi times 16, and we'll just put that in a calculator. So 4 times 13.6 equals 54.4 pi plus 16 pi, which is going to be 70.4 pi, so that's in exact form. Okay, and then to 2 decimal places, 70.4 times pi equals 221.17 centimeters squared to 2 decimal places. Okay, so you've got to make sure you're using the right information. It's pi RL, which is the slanty height, not the perpendicular height. Okay. Now, with a pyramid, it's even more difficult, really. We've got 5 faces to work out the surface area of. Fortunately, because this is square-based, we've got the square. So let's just do the square first. That's 60 times 60, so that's 3,600. Okay, that's the area of the square at the bottom. Then we've got the area of the triangles, but all 4 triangles are actually exactly the same. Triangle. So what we're going to do is work out one of them and multiply it by 4. Now, the triangle, let me just change colour. Here's my triangle here. And we know that the base is 60. What I need to know is what the height is. Okay, this will be the height. And again, I can use a bit of Pythagoras to work out what that height is. This length here will be 30. And this length we're already told is 30. This will be 30 because it's half of the 60 over here. So the height is going to be equal to, height squared will be 30 squared plus 30 squared. So let's just do that. 30 squared plus 30 squared equals 1,800. So the height is the square root of that. Root of your answer is equal to 42.4 for three significant figures. So the height of the triangle is 42.4. So the area of the triangle is going to be the base, which is 60, times height, which is 42.4, divided by 2, because it's a triangle, and then multiply everything by 4, because there's 4 triangles. Okay, so let's do that now. Times 60, divided by 2 and times 4 is equal to 5091.1688. And then we just got to add them together. So add the 3,600 and we get a surface area of 8,691.17 centimeters squared. Okay, so that is how we work out the volumes and surface areas of a sphere, a cone, and a square-based pyramid. Have a little go at working out the volume of this pyramid here. Okay, stop your video and have a go. Okay, hopefully you've realised that we need to use a bit of Pythagoras' theorem to find out what the base sides are. So we can do that. We know that, let's call this distance here x, then 12 squared plus x squared equals 15 squared. So x squared equals 15 squared minus 12 squared. Apply Pythagoras' theorem in the right way. Okay, which is 81. So x is equal to 9. So this distance is 9, which means the square base is 18. Okay, so now we can work out the volume. The volume is going to be equal to 1/3 times the base area times the height, which is 1/3 times 18 squared times 12. And just throw that into your calculator. 18 squared times 12 divided by 3. And the answer is 1296 centimetres cubed. So hopefully that was easy. Okay, what about this one? The sphere has a radius of 3. Find the volume of the sphere. So that should be easy. Volume is equal to 4/3 pi r cubed for a sphere. So it's 4/3 times pi times 3 cubed, which is 4/3 times pi times 27. Bit of quick maths here. I can cancel off that with that. It becomes 9. So 4 times 9 is 36 pi centimetres cubed. And so that is my answer there. Okay. Right, now stop your video and have a go at these, finding the volume. Okay, just the volume for these ones. Giving 2 answers. Give your answer in exact form, so in terms of pi, and to the nearest 0.01 centimetres cubed for each. Okay, stop your video and have a go. Okay, hopefully you've done that. Here are the answers. Okay, this one here probably isn't, there isn't an answer to B because it's probably an exact answer. Okay, so there are your answers. Okay, again, see if you can find the volumes of each of these shapes, giving in exact form and, if appropriate, to the nearest 2 decimal places, to the nearest 0.01. Okay. Okay, I hope you've done that. Here's the answers. Okay, any questions you're not sure about, just ask me. Okay, again, the volume for each of these 3 shapes. Find the volume of each of these 3 shapes. Okay, here are the answers. Okay, if there's any doubts about any of those, let me know. And finally, find the surface area of each of these three shapes. Again, two answers, one in exact form, and then giving it to 2 decimal places as well. Okay, find the surface area of each of these shapes. Okay, here are the answers. There we go. If there's any doubts about any of that, please let me know. I'd be happy to help you. Okay. Right, before I end this video, just have a look at this one. The student that did this, Connor, has made a mistake. Okay. He wants to calculate the volume of this cone, and here is his working out. This is what he's done here. He's got it wrong. What mistake has he made? Hopefully you've realised that the mistake he's made is that he has used the slant height as the height when really he needs to use the perpendicular height. So you would need to use a bit of Pythagoras' theorem to work out what the perpendicular height is before you actually work out the volume. Okay, Connor has used a slant height rather than the correct perpendicular height. Okay, right, there's going to be a next part where we're going to